channel with the little video titled "What are wormholes?" While that video may have answered what wormholes are, it left many of you with a lot of questions, the most important one being, are the existence of wormholes even possible? For a while now, these mysterious tunnels through space-time have been poking at our wonder, and our curiosity is only ever growing. So today, we'll be journeying further on our quest to make our wildest sci-fi dreams a reality. If you've watched the first video and possess rough knowledge of the concept of the theory of relativity, we know by now what an Einstein-Rosen bridge is and how it works. But there was one major issue which the video didn't touch heavily upon: ensuring the wormhole stays open. Wormholes are naturally very unstable and collapse nearly the instant that they're formed. To understand what I'm talking about, I need you to look around at your surroundings. You see that empty space around you? Well, what if I told you it may not be empty after all? In fact, according to quantum theory, empty space is far from being empty. It's teeming with particle and antiparticle pairs which briefly pop in and out of existence. If we zoomed in even closer, we would see that the actual curvature of space is undergoing similar fluctuations, and during these fluctuations, microscopic black holes form, which can lead to the formation of Einstein-Rosen bridges. But the thing is, these black holes only come into existence for about 10 to the negative 23 seconds at this scale, making any wormholes which may exist too small and short-lived for travel. Even light wouldn't have the time to make it through. So, if we can't even get light to pass through, how will we manage to fit people or spaceships through? Well, we can achieve a stable wormhole through the use of negative energy. For those of you who haven't been keeping up, before we go any further, let's take a look at the simple anatomy of a wormhole. The ends of a wormhole contain mouths, which are connected by a throat. Wormholes require negative energy to maintain their stability. Negative energy helps stabilize a wormhole by pushing on the walls of the throat of the wormhole, keeping the wormhole from collapsing in on itself. So how do we obtain negative energy? The answer is exotic matter, a form of matter which is not made up of subatomic particles like protons and neutrons that normal or baryonic matter is made of. Exotic matter has negative energy, but how would that work mathematically? According to Einstein's E equals mc squared, which says mass and energy are interchangeable, if our energy is negative in this case, then that means our mass is also negative. In other words, exotic matter has negative mass. It's hard to describe the physical structure of an object with negative mass, but let me put it to you this way. It's a piece of exotic matter with the mass of normal matter but with the opposite sign. Again, if you're scratching your head, don't worry. It can be a bit confusing at first, but just keep in mind the abstract concept I told you for the purpose of this video. Anyways, normal matter that makes you and I has an attractive gravitational field, meaning that it exerts a gravitational force big or small, which pulls objects towards it. Whereas negative matter has a repulsive gravitational field, meaning objects will have a force acting on them which pushes them away, which is why exotic matter can be used to stabilize the throat of a wormhole. As of now, exotic matter is hypothetical and has yet to be found. To make matters worse, cosmologists also say that negative mass violates the theory of relativity. That's because the theory of relativity only allows for anti-gravity fields with reasonable states of matter. So then scientists made some modifications to the negative mass theory and then realized that if negative mass existed in the fluid form instead of solid form, it wouldn't conflict with the theory of relativity. Although the issue of where exactly can we find exotic matter is still unanswered. However, some interesting ideas have popped up. For example, Jamie Farnes at the University of Oxford claims that dark matter and energy could be a single unified fluid of negative mass, and has even gone as far as to propose modifications to the theory of relativity and create a 3D computer model to show how it could theoretically work. Now, that theory is still under development, so it's too early to say how it could turn out, but it does open up a chance for us to look at it in a later video. After all, negative mass and exotic matter isn't a simple concept that can be explained in one YouTube video, but then again, neither are any of the fun topics in science. Speaking of fun topics, remember how I mentioned in the earlier video that wormholes couldn't just transport you anywhere in space but through time as well? How does that work? Unfortunately, we've used up all our time today talking about exotic matter, but feel free to join us for the next video.